Hi, my name is Dia, and today we're going to be talking about how we could build a quantum computer. So first, let's start off with the most fundamental question. What is a quantum computer? Well, quantum computers make use of the basic principles of quantum mechanics, which is the study of the strange things that happen to particles when they become very small, very cold, or very isolate. Quantum computing uses these properties of quantum mechanics, such as the superposition and entanglement of qubits, to carry out complex calculations faster than what would take even our current supercomputers millions of years to solve. However, quantum computers do have some parallels with classical computation, just a bit weirder. For example, you may have noticed that I just used the word qubit. Qubits are quantum bits, and they're the building blocks of all quantum computers, and what we're going to be focusing on in this video. Qubits can be the state of 1, 0, or, unlike a bit, they can be in a superposition of 1 and 0, where they can be any probability or amplitude between 1 and 0 at the same time. And this is how data is encoded in a quantum computer. There are many different methods to create qubits, and we're going to be focusing on two of the more favored ones in this video. The first method we could use to create a qubit is by using ion traps. An ion is an atom with a positive or negative charge, and here two of the distinct energy levels of the remaining electrons are used to represent the states of 1 and 0. To form the qubit, the ions are trapped in tiny wells with a pulse of light from a laser being used to nudge the ion in between the different states. Trapped ion qubits are used by the company IonQ, and this works pretty well because the ions are electrically charged, so they can be held relatively in place by the electromagnetic field. A few years after the first ion-trapped qubit was created, a new method for building qubits was created. This was the superconducting qubit and is used by IBM Quantum. This involves cooling a superconducting circuit down to almost absolute zero, so that the circuit behaves as a quantum circuit, without heat or noise disturbing the qubits and exciting them and causing an error. You may remember from your physics lessons that Planck's relation, denoted by the equation E equals hf, shows us that the energy of a photon is proportional to the frequency of an incident ray of electromagnetic radiation. This is why a flash of radio wave tuned just to the right frequency can put this superconducting circuit into one of two distinct energy levels, which represent the states 1 and 0. Follow-up zaps can then be used to steer the qubit into a superposition of these states. But what do you think? Which method of creating qubits has the best potential? Ion-trapped qubits or superconducting qubits? I hope you enjoyed this video. I'm Dia, and this is how you could build a quantum computer.